Yes, sir.
Yes, sir.
Okay, so if you put if you interchange, these conditions can be obtained by interchanging 2 and 4 in 6.5. Now let us do that. So if we interchange in the first equation, this is L1 plus L4, that is less than L3 plus L2. And the next equation, L1 plus L2 less than L3 plus L4. Next equation, L1 plus L3 must be less than L4 plus L2. Let us call this 6.6. Now just check whether 6.6 and 6.5 have any similarity.
Semi-clear.
What is the similarity between 6.5 and 6.6?
They are same.
They are
They're
same.
completely same.
Okay, so 6.6 and 6.5 are same. So that means what? That means if you just satisfy this condition of dimensions, you satisfy the condition for complete rotatability of 2 with respect to 1 and complete rotatability of 4 with respect to 1. Okay. Then in the next step, what we will do, we will find out conditions for complete rotation of link 3 with respect to link 1. Okay, to do that, so let us first draw this mechanism which we had. I'll use this color. So we had this mechanism here. This is 1. And at any arbitrary configuration, suppose this is link 2, this is link 2, and we have link 3 is here, link 3 is here, and this is link 4. This is the mechanism 1, 2, 3, and 4. 4. All right, now, so let us draw another configuration here. I draw a parallel line with link 3 and draw another parallel line with link 2. And I'm calling, so the names were O2, O4, A, B. I'm calling this point is A dash. Okay. So you can see that this O2, A, B, and A dash is a parallelogram.
Parallelogram.
Okay, parallelogram. All right. Now, and at this position, if you rotate, suppose you rotate 2 or rotate 4, whatever motion you give to all these links 1, 2, 3, will have similar motion, means 3 and link 3. So link 3 and O2A will have same motion, is it not? From this parallelogram,
Yes, sir.
it has to always
Yes.
maintain the parallelogram, right? So suppose at some other instant, the sorry, at some other instant, suppose this link 3 comes to this position. Obviously, this O2A will have this position. That means what? That means if we can ensure for any condition, if you can find out any condition for that, this O4, O2A is making a complete rotation, the same condition will ensure that link 3 is making a complete rotation. For complete rotation of O2A dash, the link 3 will also have complete rotation. Do you agree with this?
Yes, sir.
So if you agree with this, now for complete rotatability of link 3, we need to just find out what is the condition of complete rotatability of O2A dash. ठीक है? And now if you just draw all those extreme configurations with uh, link 1, so maybe this is a configuration, this is A1, and similar positions of similarly you can get other positions of other links. You can also have another configuration where you have, this is the position of A dash. All right. So just now we will just consider this link O2, O4, O2, A dash, B, O4. Okay. At one configuration, this, let me draw all those configurations. So if A dash is here, A dash B has to be of this length, and suppose O4 that at that point of time O4 is somewhere here. This is B, and okay. On the other hand, uh, the other configuration, suppose this is the position of B, and okay. So two extreme configurations again we have drawn here. Do Do you understand this? Two extreme configuration with A dash. Since AB will have similar motion with A dash B, sorry, uh, AB will have similar motion with O2 A dash. So that is why we have not drawn. Just now we have drawn this configuration of O2 A dash B O4. We want to find out complete rotatability of O2 A dash. What is the condition? And same condition will be applicable for complete rotatability of link 3. Now I am writing these conditions from this. I'm writing these conditions. So L3 minus L1. Now this is the link length L3. This is length L3 and this is L2. Okay. So in this case, first if I take this configuration, so L3 minus L1 plus L4, L3 minus L1. So this length plus this length must be less than this length. Okay, must be this two must be greater than L2. Okay, that is one condition. From this we can write down L1 plus L2 is less than L3 plus L4. Okay, on the other hand, if you have the same condition here, you apply this length plus this length must be greater than L4, which gives you L1 plus L4 is less than L2 plus L3. And from this extreme position, so this length,
So what is second equation?
this equation, you are asking about this equation.
Yes, sir.
So you see this length plus this length. Okay. No. So
Yes, L2
this
then.
this is not the case. This would be L2. Okay. Now it's fine. Is it fine? This
Yes.
length plus this length must be greater than this length. Okay, from the triangle. And now for this extreme position, you see L1 plus L3, L1 plus L3 must be less than L2 plus L4. So the last condition is L1 plus L3 must be less than L2 plus L4. Okay. So let us call this 6.7. Now you compare with, if you have your note here, you can compare, they are the same relations. So 6.5, 6.6 and 6.7 are the same relation. So this is the relation 6.7 gives you the condition for complete rotation of link 3 with respect to link 1. Now this is the only condition you have. This three condition, three inequality gives you the complete rotatability of link 2, link 3 and link 4 with respect to link 1. Okay. Now further simplification we can make. What we can do, add any two inequalities. So just add these two inequality, this one and this one. What you'll get? Can somebody tell me what you get?
L2 greater than L1.
L2 greater than L1. Now add these two. I'm not verifying. Just add these two and tell me what you get.
L3 greater than L1 of first.
And now if you add this one and this one,
L4 greater than L1.
L4 greater than L1. So finally, that means actually from these inequalities, 6.7 can also be written in this form. Let us call it 6.8. That means this is the condition. And what is this condition? This condition is saying that L1 has to be the shortest link. L1 is the shortest link. Okay. So if L1 is the shortest link, then with respect to L1, all other links can have a complete rotation. Okay. L1 is the shortest link. So with respect to L1, all other links can have a complete rotation. All right. Now, from here, can you see that this is proved? L1 is the shortest link. Okay. That is always less than other two links. Okay. And then if you use these inequalities again, then you will have these three inequalities are nothing but this one. You see that in all these three inequalities, you have L1 this side, and L1 is the shortest link. Okay. So we have proved that with this rotatability of other links with respect to one is complete rotatability is given by this relation, shortest link. Okay. Now this is all about rotation of this link 2, 3 and 4 with respect to 1. Now can this link 3 rotate with respect to 2 or 4? Means we have now got the condition for rotatability of link 2, 3 or 4 with respect to 1. Now can these 3 rotate with respect to 2 or with respect to 4? That also we need to find out. What is the condition? So suppose rotation of, now if we explore rotation of link 3 with respect to rotation of link 3 with respect to link 2 or link 4, that we need to explore. So let us draw the extreme positions. When link 2 and link 3 has to, means link 3 is completing a rotation with respect to link 2, there would be a configuration. Obviously, there would be a configuration like this. So this is if this is link 2, this is link 3, then there must be a configuration like this. Okay, because 3 is making complete rotation with respect to 2. So at one time will be there when they'll be on the same line. So if they are on the same line, then they have to satisfy this relation L2 plus L3 must be less than L1 plus L4, right? L2 plus L3 must be less than L1 plus L4. Can we have this relation from here? If you maintain this condition, and this condition gives you this, where you see L2 plus L3 always greater than L1 plus L4. That means this condition is not satisfied. I'll take 2 more minutes to finish this. Okay. On the other hand, if you want to check the rotatability of link 3 with respect to link 4, then you will have a configuration like link 4 is here and link 3 is here, although according to our drawing the dimensions will not match, and that is obviously that is also a inspection. You see, as we have drawn, link to length is not this much, but for to prove this, let us say this is 4 and this is 3. Now what is the condition for this extreme position? We are saying that link 3 will rotate with respect to link 4. That means there is an extreme position like this. At one point of time, link 4 and link 3 has to come on a straight line. Okay. So then for this case, we should have this condition link 3 plus link 4. This must be less than link 1 plus link 2. Let us go back to these inequalities. Link 1 plus link 2 is less than length of link 3 plus link 4, which is also not satisfied. This is also not satisfied. If these two things are not satisfied, then from this we can say that link 3 can not complete a rotation with respect to 2 or 4. Okay. Once you have these conditions, once you have this, there are two things we have. One is if L1 is the shortest link, then all the other links can rotate with respect to 1. For the same conditions, link 3, this 3 cannot rotate, cannot make a complete rotation with respect to 2 and 4. So always with respect to 2 and 4, you can make this link 2 fix, you can make this link 4 fix. This link 3 will not have any complete rotation with respect to 2. On other words, 2 cannot have a complete rotation with respect to 3. That means 3 can always have, this link 3 will have always oscillatory motion with respect to 2. In other words, 2 will have always oscillatory motion with respect to 3. Similarly, 4 can have oscillatory motion with respect to 3, or 3 can have oscillatory motion with respect to 4. And all these three links, 2, 3, 4, they can have complete rotation with respect to 1. Okay. And when you have understood all these conditions, then only you can have this double crank rocker and double rocker mechanism by fixing these links 1, 2, and 3. Okay. So can you tell me when you will get this double crank mechanism? For which condition you will get double crank mechanism? Which link we have to make fix?
Shortest link.
Yes, when you
L1.
fix this link 1, then you will have double crank mechanism, because double crank mechanism means link 1 is fixed and you are making this, suppose this link 2 is crank, you rotate it completely, so 4 will also rotate complete rotation. But 3, as you say, that 3 will not have complete rotation, means 3 can have complete rotation with respect to 1, but 3 have oscillatory motion with respect to 2 and 4. Okay, so when you will get this crank rocker mechanism,
On fixing 2 or 4.
if you fix 2 or 4, then you will have crank rocker mechanism, because if you fix 2 with respect to 2, 1 can have complete rotation. When you fix 4 with respect to 4, 1 can have complete rotation. So that means 1 is the crank here. On the other hand, so if you fix 2, crank is 1, 3 is the follower. So 3 will have the, this will rotate, this will complete rotation, but 3 will have only rocking motion. On the other hand, if you fix 4, 1 can rotate, but 3 will have. So that is a rocker motion. And what is left? Double rocker. When you will have double rocker,
Fixing link 3.
you fix link 3, 1 can have complete rotation, but 2 and 4 will always have oscillatory motion with respect to 3. Okay. So here we complete the discussion. I have taken 5 minutes more. Here we complete the discussion. I left this writing for you. Just complete this. Which mechanism you get by fixing link 1, link 2 or 4, and link 3. Okay. This gives you double crank. This gives you crank rocker. And this gives you double rocker. Okay. Fine. The lecture notes are uploaded in the team. If you want, you will get that. Right. If you have any question, you can ask me. Otherwise, I'll thank you for your attention. Class is over. And today's lab will be conducted by the TS. Okay. If you have any question, you can tell me, ask me. So next class we will start dimensional synthesis. Okay. All right. Thank you.
Thank you, sir.